Hello and welcome to the next edition of the BriefingsDirect Voice of the Customer podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on digital transformation success. Stay with us now to learn how agile businesses are fending off disruption in favor of innovation. Our next high-performance computing success story interview examines how Pittsburgh Supercomputing Center has developed a research computing capability, Bridges, and how that's providing new levels of analytics, insights, and efficiencies. We'll now learn how advances in IT infrastructure and high-performance computing architecture are combining to meet the new requirements for artificial intelligence, big data analytics, and deep learning. Here to describe the inside story on building Bridges, we're joined by Dr. Nick Nystrom. He's Senior Director of Research at Pittsburgh Supercomputing Center. Welcome.
Good morning, Dana. Pleased to be here.
Glad to have you with us. We're also here with Paola Buitrago, Big Data and AI Specialist at Pittsburgh Supercomputing Center. Welcome.
Thank you, Dana. Pleasure to be here.
We're glad to have you with us. Let's look at what makes Bridges unique. What is it about Bridges that is possible now that wasn't possible much more than a year or two ago?
Bridges allows people who've never used high-performance computing before to use it for the first time ever. These are people in business, the social sciences, different kinds of biology and other physical sciences, and people who are applying deep learning and machine learning to traditional fields. They're using the languages, the frameworks that they've been using on their laptops and now scaling it up to a supercomputer. They're bringing big data and AI together in ways that they just haven't done before.
It almost sounds like the democratization of high-performance computing. Is that one way to think about it?
It very much is. So we have users who are applying tools like R and Python and scaling them up to very large memory, up to 12 terabytes of RAM. And that's letting them answer problems they've never been able to answer before.
So there's a user experience aspect to it, but I have to imagine there's also a underlying infrastructure benefit as well. Is there something about the performance capabilities now that's enabling Bridges that then helps to provide that user experience democratization?
So yes, the democratization comes from really two things. The first is we stay very closely in touch with the user community. And we looked at this opportunity first from their perspective. What are the applications they need to run? What do they need to do? And from there, we began working with hardware vendors to understand what we had to build. And what we came up with was a very heterogeneous system. We have 3 tiers of nodes having memories ranging from 128 gigabytes to 3 terabytes to 12 terabytes of RAM. That's all coupled on the same very high-performance fabric. We were the first installation in the world of the Intel OmniPath Interconnect. And we designed that in a custom topology that we developed at PSC, expressly to make big data available as a service to all of the compute nodes with equally high bandwidth, low latency, and to let these new things become possible.
How can the opportunity for you to use such a platform as Bridges be an important element of big data analytics? What is it that you gain from this platform?
Well, a platform like Bridges enables things that were not available before. Like that's going back to your earlier question. So there's this case with Libratus that was described by Dr. Sandstrom. This is something just a perfect example of something that couldn't have been done without the supercomputer. Supercomputer enables having big models, complex models that can actually give an accurate answer. Right now, we all know we are collecting a lot of data. Like there's the convergence of having like great capabilities in computing and storage, and also having the data to really answer important questions. So having a system like Bridges that allow us to go back to, for instance, analyze all that there's in the internet and come up with finding the right pieces together and answer big, societal or healthcare related questions.
And Nick, the Bridges platform has been operating for some months now. Tell us some examples of use cases that demonstrate this potential that might open the eyes of others who maybe hadn't thought about HPC as an opportunity for them in their situation in their industry.
Paula mentioned the use case for healthcare. So one of these is that we have an NIH Center of Excellence in the Big Data to Knowledge program. It's called the Center for Causal Discovery. And that we're actually looking at mining very large data in genomics, lung imaging data, and brain fMRI data to come up with real cause and effect relationships among those very large data sets. That was never possible before because the algorithms had not scaled. That's now possible with very large memory, and because the data had not been available. In Pittsburgh, with University of Pittsburgh, we have those resources now, and people are making discoveries that will improve health. There are many others. One of these is on the Common Crawl data set, which is a very large web-scale data set that Paola has been working with.
About the Common Crawl, this is a data set that collects all the information in the internet, and is currently available in Amazon in their S3 solution. They host this data set for free, but when you want actually to analyze the data, to not search or create an index, you have to use their computing capabilities, which I guess it's a good option. However, given the scale or the size of the data, this is something that would require a huge investment. So we are working on actually offering the same data set and put it together or place it together with the computing capabilities of Bridges in order for the, academia community at large, so they can do their, build natural language processing models or analyze or do engrams, and they can do it fast, they can do it for free of charge, and they can enable different science. So that's, for instance, an important example of what we are doing and how we want to support big data as a whole.
Right now, we've spoken mostly about technical requirements and performance, but economics plays a role here. Many times we've seen in the evolution of technology that as things become commercially available or off-the-shelf technologies, that they can be deployed in ways that not only were technically not possible, but just weren't economically feasible. Is there an economic story here to Bridges, and will the next iterations, the next chapter in this, be benefiting from some of the economic shifts we're seeing in memory-driven computing and edge computing?
They will. So with Bridges, we designed a system that would be extremely cost-effective. That's part of why we designed the interconnect topologies we did. It was the most cost-effective way to build that for the size of data analytics we had to do on Bridges. And that was a win. It has been emulated at other places. So what we are offering is available to research communities at no charge. And that's anyone doing open research. It's also available to the industrial sector at essentially a very attractive rate because it's a cost recovery rate. And so we do work with the private sector. We are looking to do even more of that in the future. So the future systems we're looking at, we're of course leveraging lots of developing technologies. We're always looking at the best available technology for performance, for price, and then architecting that into a solution that will serve research.
And we've heard a lot recently from HPE about their advances in memory processing, memory-driven, memory-intensive architectures. Does that fit into your plans? Is that something you're keeping a keen eye to?
So right now, large memory-intensive architectures are a cornerstone of Bridges. We're doing a tremendous amount of large-scale genome sequence assembly on Bridges. That's individual genomes, and it's also metagenomes, with important applications such as looking at the gut microbiome of diabetic patients versus normal patients and understanding how the different bacteria are affected by and may affect the progression of diabetes. That has tremendous medical implications. And so we've been following memory for a very long time. We've also been following various kinds of accelerators for AI and deep learning.
Can you tell us a little bit about the platforms that support this that are currently commercially available and what might be coming next in terms of Gen 10, for example, with HPE, or advances in their efficiency and cost reduction around storage. What are you using now, and what do you expect to be using in the future?
So the advances I see are, first of all, I think the acquisition of SGI by HPE was very strategic. Prior to Bridges, we had a system called Blacklight, which was the world's largest shared memory resource. It's what taught us how productive that is for new communities in terms of human productivity, because that's what we can't scale. We can't scale smart humans. And so that's essential. In terms of storage, there are tremendous opportunities now for integrating storage class memory, increasing the degrees of flash, and other stages. We've always architected our own storage systems, but now, of course, we're working with HPE to think about what we might do for our next round of this.
Great. For those folks out there listening and reading this information, if they hadn't thought that HPC and big data analytics had a role in their business, why should they think otherwise? It seems to me this has a role in just about everything nowadays when you think about what AI and deep learning are capable of. What are some of the lessons that business people should be thinking about when it comes to these recent advances in HPC?
Let me start this one and then hand it over.
Okay.
So I think from my perspective, I'll hand over to Paula momentarily. My perspective is that AI is permeating all aspects of computing. And the way we see it important in an HPC machine is that it's being applied to applications that were traditional HPC, things like weather, things like protein folding. And those were things that people used to run on just big iron. Now they're integrating AI to help them find rare events, to help them do longer-term simulations in less time. And I think that'll be true across other industries as well, is that there will be enterprise workloads where AI has a key impact. And it won't be necessarily turning companies into AI companies. They'll be using AI as an empowering tool to make their other things they're already doing better.
Another example, Nick?
So I think a real good example of the way AI is permeating other fields is people at the Pitt Institute for Personalized Medicine and Carnegie Mellon Machine Learning who are working together in a project called Big Data for Better Health. And the real objective there is to apply state-of-the-art machine learning techniques, including deep learning and others, to integrated genomic, patient medical records, imaging data, and other things to really move toward realizing true personalized medicine.
All right. Before we sign off, we've heard an awful lot, too, about hybrid IT. And I think traditionally HPC is required strictly an on-premises approach. The data sets are often very large and require physical proximity. But as we look to ways to garner more efficiency in a hybrid environment, to what degree could HPC as a service make sense, and to what degree can the data and the processing maybe be architected in such a way that you can take advantage of cloud models? Nick?
That is actually a very good question. One of the things that Bridges makes available through what we talked about before, democratizing HPC, is big data as a service, HPC as a service. And it does that in many cases by what we call gateways. These are web portals to specific domains. The Center for Causal Discovery that I mentioned before has the Causal Web, which is a portal. It can run in any browser. And it lets people who are not experts with supercomputers access Bridges without even knowing they are doing it. They can run applications with a supercomputer as a back end. There's another example called Galaxy, which is primarily for bioinformatic workflows, but also other things. The main Galaxy instance is hosted elsewhere, but people can run very large memory genome assemblies on Bridges transparently, again, without even knowing they're doing it. They don't have to log in. They don't have to understand Linux. They just run through a web browser, and they can use HPC as a service. It becomes very cloud-like at that point.
Depending on the use case, an environment like the cloud makes more sense, or high-performance computing. It can be that at an initial stage you want to explore different artificial intelligence models and you want to fine-tune it, and you need to have that close to the data and be able to, I don't know, reduce the times, and having a supercomputer available for a week or two can let you find the right parameters. Then you have the model, and then when you are actually doing inference, you can go to the cloud and just have it answer high peaks if the user demand behaves like that. So it's complementary, and different use cases would call for different environments and different solutions.
All right, before we sign off, a quick look to the future. What do you expect to come next? Bridges has been here for over a year. Let's look to a year out. What might be the next chapter in high-performance computing in a hybrid environment, as a service, and democratized?
So Bridges has been a great success. It's very heavily subscribed, fully subscribed, in fact. And so what we've built seems to work. People are liking it. So we're looking to build on that. We're looking to extend that to a much more powerful engine, where we've taken all of the lessons we've learned and proven in Bridges, and would like to extend that by orders of magnitude to deliver a lot more capability, and that would be across both the research community and industry.
And what would be some other services that we should look for in the future when it comes to a more rich portfolio of big data as a service offerings?
Sure. We are working currently on a project to make data more available to the general public and to the researchers. So here we're trying to democratize data and let people do searches and queries and processing that they wouldn't be able to do without us. So we are integrating big data sets that go from web crawls, the common crawl one, once again, genomes, and we are exploring what genome sequencing, and we are exploring other data sets, and we want to offer them to pair with the tools to properly process them, and eventually examples to let people that haven't done this in the past explore their questions and try to answer them based on data. So that's something we are really interested on, and we are looking forward to have get it to a production stage.
Well, very good. I'm afraid we'll have to leave it there. We've been examining how the Pittsburgh Supercomputing Center has developed a research capability, Bridges, and how that's providing new levels of analytics, insights, and efficiencies. And we've learned how advances in IT infrastructure and high-performance computing architecture are combining to meet new requirements for such uses as artificial intelligence and big data deep learning. So please join me in thanking our guests. We've been here with Dr. Nick Nystrom, Senior Director of Research at the Pittsburgh Supercomputing Center. Thank you, sir.
Thank you.
We've also been here with Paola Butrago, Big Data and IT Specialist at Pittsburgh Supercomputing Center. Thank you.
Thanks, Dana.
And thanks also to our audience as well for joining us for this BriefingsDirect Voice of the Customer Digital Transformation Success Story. I'm Dana Gardner, Principal Analyst at Intra Arbor Solutions, your host for this ongoing series of Hewlett-Packard Enterprise-sponsored interviews. Thanks again for listening. Please feel free to pass this along in your IT community, and do come back next time.